My name's Eric Sondhi. I'm from ARM. I'm here to talk to you about how, through partnership with Octopus, we are aiming to enable developers to be able to build, test, and deploy their software everywhere that ARM is, from cloud to edge. And I'll get into a little bit more about what that means. But I'm really thrilled to be here. And I'm going to start with a little intro about what ARM is for all of you, because not every developer is familiar, especially the higher up the stack you might be, and depending on your experience. I'll go through why now is the time to really start to consider what your architecture you're deploying your software on, what some of the things we at ARM are doing to help you, to help it make it very easy for you to deploy on ARM devices, whether in the cloud, whether on mobile devices, whether laptops, whether it's your automobile. We're trying to make it as easy as possible for developers everywhere to adopt our technology, to make the most of it, and make their applications the most power efficient and energy efficient and performant as possible. And we're also getting into this partnership that John just outlined. So with that, I'll just get right into it. ARM is everywhere. We have over 300 billion ARM-based devices shipped everywhere. Almost every single mobile device, laptop, smartphone, runs on the ARM architecture and is powered by a lot of ARM instruction set optimized software. And we've also been all over embedded devices. Think Raspberry Pis, to Arduino devices, and also a lot of large screen compute, desktops, laptops. We're everywhere. And increasingly over the last several years, that also includes the cloud, where most cloud service providers are now providing ARM-based services. 100% of the largest ones already have multiple generations of ARM-based servers available. And our developer community is massive. And the levels of developers that we support, all the way from the bottom of the stack close to hardware, all the way up to the top, and everything in between, whether it's ML frameworks like PyTorch, or tool developers, or microservice architecture, system engineers deploying to the cloud, all kinds of developers across the whole gamut. And so today we're going to really hone in on more of the cloud part of it, and deployment to the cloud. But just know that everything we're doing with Octopus is to enable you to deploy everywhere that you are. And I'll get into more of that shortly. Okay. 50% of the compute shipped in the to the top hyperscalers this year will be ARM-based. We're really thrilled about that. That's a massive milestone. That's something that's a surprise to many folks. They're very used to other architectures in the cloud and servers. They don't think of ARM often as providing the compute that's there in the cloud. But what's really interesting is there's massive adoption across all major cloud service providers, so much so that they're running their own first-party applications and services on ARM's architecture. Now, we've taken what has been very strong in the mobile space, our power-efficient heritage as an architecture, our energy efficiency, our area optimization, and we brought that into the cloud to deliver some of the most performant nodes. Graviton just last week, Graviton 5 was announced at AWS and reInvent. So they're on their 5th generation, empowering so many different end user-facing applications, and not to mention the third-party support for ARM that's all over the AWS marketplace has really just exploded over the 5 generations of Graviton. And that's not just AWS, right? So Axion, just in the last month, these 3 cloud service providers have announced their next generation ARM servers. Axion and Google Cloud has a second node, N4A, that complements their V4A to provide several first-party applications and software, and as well as a wealth of third-party apps. And Microsoft announced a second generation of their Cobalt architecture, and other cloud service providers from Oracle to several CSPs in China are also running on ARM and providing their services on ARM. So what the energy efficiency we get in the data center means is a significant lower cost in deployment of ARM for the service provider. And that often means to you, the end user, a significantly lower cloud bill. And that is driving a lot of software vendors and system integrators to adopt ARM and use ARM and make ARM their primary choice. So we have just a massively growing software ecosystem, all the way up the stack, from the Linux low level to Linux distributions, device driver environments, out to cloud native communities and Istio, like we were just hearing, and Kubernetes, and then also the software ecosystem that supports these large developer communities. We engage through partnership, whether it's Docker and making sure there's wonderful Docker support for ARM, no matter what platform you're running on, or GitHub and the latest developer experience that might be agentic or DevOps, MLOps focused. We want to make sure ARM is there and easy to adopt natively in that GitHub experience. And I'll talk a little bit more about that. And then we cover SaaS and enterprise very broadly, and also the AI and ML frameworks and models and distributors that are out there, everyone from PyTorch to Llama CPP to TensorFlow to Hugging Face, all have ARM's presence really strongly represented so that developers can really easily adopt us. What we've done with GitHub in the last couple of years is we made ARM servers, this new class of ARM server over the last several years. We made it readily available to any developer on GitHub. Starting in June of last year, right, we announced ARM64 servers available just in a preview mode, right, to provide the lowest cost ARM servers available for runners, the lowest cost ARM runners natively available under GitHub, make that readily available to enterprises everywhere. Since then, we've deployed native Windows runners. We've also deployed native low-cost runners for the open source community and for public projects for free, thanks to our friends at GitHub. And then just in August, they made ARM runners generally available. So the adoption has been enormous. It's really wonderful to see more and more everyday developers choosing ARM for their build and test. And we're really eager to continue our partnership and make the native experience even more seamless. We continue to work with GitHub and other partners to make it easy to migrate and adopt ARM. And we do all kinds of things, from providing tooling and the ability to assess the value of moving to ARM through total cost of ownership calculators and migration tools, to performance tools to understand how your workload performs, how to benchmark, how to monitor, and how to enhance the performance and tweak and improve the performance, to a latest class of AI-assisted development tools to enable agentic AI workflows and to enable GitHub's Copilot environment that they've gone full force with enabling agentic workflows through custom agents just recently at GitHub Universe. And in order to do this, we've kind of taken and created an MCP server that's backed by really three pillars: a range of tooling that help analyze your code base or analyze your containers or your dependencies and ensure that there's ARM support there readily, that matches the latest versions of dependencies, that makes easy, simple tweaks to your containers to make sure they're multi-architecture, and that make changes in your code base to help ease the migration. And this collection of tools is paired with a really robust knowledge base of public information, tutorials, what we call ARM learning paths, ecosystem dashboards that have all these libraries of supported ARM dependencies, intrinsics database, so you know how to micro-architecturally optimize certain elements of your workload. All of that knowledge from ARM experts is just packaged up into the knowledge behind our MCP server. And then we have some prompts that are refined to really help with very focused use cases that typically occur during the migration process. So simple prompts that will help analyze the code base, deploy an agent to that code base, and scan for dependencies and make sure that dependencies are matched or upgraded. They will also do things like look for opportunities to employ intrinsics or micro-architectural enhancements, or actually do some porting. They will also scan containers and make sure that your containers can be supported and can run on ARM. And if not, provide suggestions or enhancements or upgrades to the dependencies in your packages. They will also just make the container composition multi-architecture for you if it is capable, and actually just make your container ready. So we've taken this MCP server and we made it integrated into a number of different agentic workflows. And we're really thrilled about what we've done with GitHub Copilot. Here's an example of the MCP server running under GitHub Copilot, and here the migration agent uses our MCP server to make the architecture easier. You just specify a new issue, write a simple title, migrate this repo to ARM. Really simple description. Use whatever MCP servers you need. So you could specialize its usage to specific tools, or you could just make it general. Give the whole branch assignment to this custom agent, and get the agent working for you. It'll start to work in the background. You can watch it work. You can leave the agent and come back when it's finished. And then once you go take a look, you'll just see what's happening. Their agent will already configure and download the localized MCP server image. Make sure it gets started. You'll see the suite of tools that are used and how they might be used to perform your migration. So you can kind of really watch what's happening in real time, or you can come back and look at things afterwards. And just all you have to do is go check out the pull request. Here we can see that the agent decided to look at the Python data processing pipeline, migrating it to ARM, looked at the base images, making sure there was compatibility, upgrading it, looking at the packages, looking at where the compatibility needed enhancement, making sure the container was multi-architecture to build, and went ahead and made a bunch of suggestions and changes and documentation to support that. You can see all of the changes that were made. You can review them. So you have that human in the loop element to not just oversee the migration, but to also learn what was done and become an expert yourself. Look for more opportunities. If you're satisfied, merge the PR, and then you're done. So we think this experience is really going to change the game. ARM has excellent documentation. ARM ecosystem has wonderful tools out there, but to take yourself out of your flow state, go delve into deep CPU-centric documentation when you're just trying to deploy AI in your application, it really takes you out of your zone. We bring this all that wealth of knowledge and experience and technical information right into the agentic workflow, and working alongside with GitHub, you can take advantage of the general coding agents that are available under Agent HQ, or the ecosystem of custom agents like from partners like Octopus Deploy. And we'll talk a little bit about that as well. Bear with me a second here. I'm just going to move this forward. Okay, so in summary here for the migration assistant, we built this is by developers for developers, the developers at ARM that are continuously deploying software to the open source community, Linux distributions, making tools. They built this for themselves, and they also know that what your developer experience is like, and they want to provide you the very best of what ARM can offer and what ARM knows. And with this, we think that there's a wonderful end-to-end automation flow that will help you with the migration process. Now, building and testing with ARM runners and lowering your cost is wonderful. Helping you with AI-assisted agents is also awesome for the developer experience, but there's a piece missing, and that's deployment. Actually getting your software out to where it's going to run and live in staging and in production. And that's where our friends at Octopus really shine. I couldn't be a bigger fan of of the team at Octopus, John, and everything that you do. And so we really have started and announced a partnership. John mentioned the blog to really help centralize, secure, and make repeatable the software delivery to ARM-based systems. There's already wonderful support for continuous delivery at scale from x86 to ARM servers across multiple cloud service providers. And there's already excellent support for compliant and secure CD with Kubernetes edge deployments. And these areas are where we're really going to focus in the next several months. So you're going to get to learn a lot more about the best ways to employ everything I showed you with GitHub and in other environments, and what Octopus has together to build, test, and deploy everywhere, and have a complete workflow. And what Octopus has done is not really new per se. They've had long-standing support from ARM. Back in 2021, they announced Tentacle for ARM64, really focused on kind of more edge servers, Fat Edge, Raspberry Pi, AWS EC2 instances, or really any hardware that had certain dependencies on .NET. And that Tentacle already got some wonderful adoption, and it was really clear how useful and broad the deployment story could be with ARM from that. But what we really feel is that with this change in momentum, the volume of ARM servers being deployed and made more accessible to all of you, we think that there's a real opportunity here to, with this announcement, simplify multi-architecture deployment so that you can deploy your software everywhere on whatever architecture you need, whether ARMS or elsewhere, and take advantage of all the compute that's out there, because more and more compute is needed to deploy more and more of the applications everywhere that you're deploying. We also understand that it's not one cloud service provider all the time. There's complex deployment that involve multiple cloud service deployment. And the ARM architecture is a common link across all of the cloud service providers I mentioned that have ARM-based servers. So we believe that with working with Octopus, we can provide a really foundational layer for deployment and recipes that you can replicate in a very native deployment strategy and CI/CD solution off the shelf that will handle very complex multi-cloud deployment on ARM that will also lower your cloud bill and enhance your developer experience and your deployment experience. I really believe in what Octopus does really well with hybrid cloud management. And I think that's another area where a lot of ARM technology is on-prem, especially when you think cloud to edge, cloud to car, right? The development environment involves, sometimes a local rack of boards or a board farm, a fat edge server that is very different from the servers that are in the cloud. So I think this environment can be managed when you have solutions like the things that Octopus Deploy provides you all, and when there's very seamless ability to deploy on any architecture and support the ARM architecture, it will just make your deployment story much more easier and scalable to manage. And I think we're very excited about the future of agentic development. Both companies, as GitHub launched their custom agents for GitHub Copilot from partners, on day one at GitHub Universe, ARM and Octopus were there with custom agents, with MCP servers, ready to go with use cases that were very applicable to our customers. And I think the agent-to-agent opportunity here is really exciting to really have a full, seamless workflow that you can handle the build and test natively on GitHub. You can deploy where your actual deployment is with Octopus Deploy, and you can have agents manage the migration details for you, the errors in migration, when the errors in deployment, and the resolution, potential resolution to outages, issues in your CI/CD over time. And that's a story we're really looking forward to developing with our friends at Octopus. And to learn more about how things actually work with the Octopus solution in real world use cases, I invite you to join us on January 22nd for a webinar where Octopus, our friends at GitHub, myself, and our friends at AWS will talk about how all of the pieces come together in an AWS environment to build, test, and deploy on Graviton in a very seamless, fluid way that takes advantage of the very latest and greatest agentic technology, that takes advantage of the very latest and greatest Graviton technology, Graviton 5. And we're really excited to bring this to you and really get into the details. Today, it's a little more high level to get you conceptually aware of why we partnered with Octopus. And we're really looking forward to a deeper show and tell with you all on the 22nd. I'll also leave you with a couple other opportunities here. We have the MCP server that I mentioned. It's currently in a beta. We've actually extended the beta a little bit. It will be generally available soon. But if you want to get started today with a GitHub custom agent and start trying this and maybe give us some feedback and work with us a little bit, sign up for our beta program. We'd love to hear your thoughts on how our agent can work with Octopus's agent or your own agentic environment. What are some of the gaps or what are some of the opportunities? Because we're in very early days with this. So our hands open for you now. And then lastly, we'd love for you to join the ARM developer community and take advantage of all the wonderful resources that are available directly. So you can become a member. You can meet other members of the community across different markets as well, and learn from developers at Meta, at Google, at AWS, all over the ARM ecosystem. And it's just a wonderful place to learn and grow and develop. So I'm just going to flip back to our webinar here. I think that's nearing the end of my time with you all. Covered a lot of ground. Thank you for the time. Thank you for hosting me, John.